Okay, so in our last video, we made this plan, and I'm just finishing up this plan by converting it from pseudocode into Python. As you'll note, my pseudocode has become more and more like Python, and so, if you don't know how to approach a problem, or like a specific line, try to just write it in English, and then you can worry about the syntax later. But if you're really familiar with the syntax, like if you know exactly what you're going to use, like insert, then you can just kind of, or if you're wanting to talk about like a position in the array, rather than saying the element at nums2 located at nums2 index, you can just sort of write it like that, and that's totally fine. Whatever's shorthand for you. Okay, so then let's figure out how do we insert nums2 at nums2 index into nums1. Well, in Python, the parlance for that is, remember that we want to operate on nums1. We're modifying this in place. We could say insert, right? The first argument is where to insert it, and so that's going to be nums1 index. So it's going to put it in, if we had nums1 index was 1, then that would be this element. And so what we want to do is we want to insert it at this index, and then we want to insert this element, not the index, but the element itself, into nums1. And so what this would be when this is 1 and this is also 1, we would take this 2 and we would put it in the front so that it is now at position 1. And so it will shift everything over, making our list temporarily longer. And that way we got it. At that point we have to turn, yeah, there we go. At that point we have to get rid of that last element. So then we can go nums1 dot pop. And if we don't pass anything in, that's the end element. Okay, so let's run this now. All right, what do we got? Int object has no attribute insert. Okay, so, we don't want to call it there. We want to call it right there. Okay, run that. Cool. Okay, so we got totally the wrong answer. So what do we have here? Let's see. I think this actually needs to be this direction. I think that was what was wrong. There we go. Okay, so it looks like what we were supposed to get was 1, 2, 2, 3, 5, 6, and what we got was 1, 2, 2, 3, 5, 6. Okay, so let's just run this through in Python Tutor real fast, and just watch it execute. It'll help us understand what's going on. Okay, so we dimension the thing, we create these two lists, and then we're going to merge these sorted arrays. So remember that you can see here that nums1 and nums2 are pointing to something that exists outside of the function. These two lists exist outside of the function, and so they're not like being redimensioned and then deleted at the end. We're operating on nums1. Okay, so now we create some indexes, and then while we haven't hit the end of nums2, we're going to check to see if we're going to check to see if 2 is bigger than 1, right? It isn't, so we're just going to move forward by 1 in this list. So now we're looking at this and this. Okay, and so that is in the right place, so we're going to do an insert. You see how that 2 just appeared there? Pow. And then now this list is a little larger. So then we're going to pop that 0 off the end. And then we're going to increment the nums2 index. So now we're dealing with 5, and we're still dealing with this 2. So now nums1 index will increment a couple of times until we get to a spot where it is found the zeros. So now we're going to start putting 5 there, and then delete that last 0, and then we'll put 6 there, and delete that last 0. And there we found our end value. So that's how you translate this into Python code. This is a single pass-through. we're only counting the largest array, right? Because what we're doing is we're kind of comparing both of these lists. We're not trying to like loop over the list again and again. So we don't, once we've found that we've reached a 0, we don't have to like go back and check this. And so this solution is linear because we're maintaining windows and pointers rather than kind of relying on the operations like if in or find, right? Those operations cause us to kind of look over the list over and over again, and they make our solution not linear. So yeah, that's how we solve this. This is sort of a sub-problem in many other problems. So you'll run into this problem again, but you'll probably encounter it in a larger problem.